Hi, I'm demoing CGM prediction using RNN based model. The data file is over here. So let me start with the code. Over here, we do a bunch of imports which are needed for the code file. And then first of all, we pre-process the data to bring it into a format which can be fed into the model. Uh, what we do is we load the data file over here, and then we get the CGM data and the OLS data. Uh, we extract the date time from it, and then over here we merge it. So once you merge the data for the food intake and the CGM time, it looks something like this. In the next step, what we're going to do, we are going to change the bolus column over here, and whatever value is less than 1, we just make it 0. Whatever is greater than or equal to 1, we make it 1. And for the values which are not available, we make it 0 as well. Next step, we get a rolling mean from the CGM data above, this one, and we start modifying this data to bring it into a format which can be fed into the model. For the training data set, we use from all the data that is present in the insulin glucose data to map file, we use 70% of it. And then for validation, we use 10% of the data. For the training data set, we use the remaining 30%. After that, we use a scalar normalization to bring all the data into the range of 0 and 1. That way, it is normalized and the model can run on it. So we just do like a bunch of time series generation for the scale data set. We have training data, validation data, and test data over here. Next, we define the model, and what we do is we train the model based on the training data set. So once you run this code, this gets generated, and later on the same, sorry, later on the same training data set, we predict using the test data which we generated above. Now, once this is predicted, we again inverse the scalar normalized form to actual LSTM predictions. That way, they can be mapped on the graph for the actual data values, and we can see how close they are to the predicted values. So over here we plot it. As you can see, the graph follows a close similarity with the actual data set, and at some places it does diverge, but more or less it sticks to the actual data. The predicted data is close to the actual data. This is just a zoomed in version of the graph over here. We finally find the RMSE and MAE. So it comes to 6.33 and 3.2, and later on we run this function to find the test accuracy, which comes down to 76.77% for this running instance. That is all. Thank you.